So in this question, they have given the two real sequences. One is x1, x2, x3 and so on. Another one is y1, y2, y3 and so on, are defined as xn plus 1. The first series, xn plus 1 equals to xn plus under root 1 plus xn square, right? This is the first sequence that has been given to us. Now let xn be equals to tan theta n, where theta n is in the first quadrant, right? So what is coming? We are getting xn plus 1 as tan theta n plus sec theta n. So that gives us sin theta n plus 1 divided by cos theta n. So that gives you cos theta n by 2 plus sin theta n by 2 whole square divided by cos square theta n by 2 minus sin square theta n by 2. Is it clear? So we are getting basically cos theta n by 2 plus sin theta n by 2 divided by cos theta n by 2 minus sin theta n by 2, right? Now dividing numerator and denominator by cos theta n by 2, we are going to get 1 plus tan theta n by 2 divided by 1 minus tan theta n by 2, right? So that gives us tan pi by 4 plus theta n by 2. So what we got? We got x n plus 1, which is equals to tan theta n plus 1 is equals to tan pi by 4 plus theta n by 2. Is it clear? So that implies theta n plus 2 is 45 degrees. I'm writing it in degrees plus theta n by 2. Is this clear to all of you? Absolutely. Now you see, they have been given that x1 is root 3. What is x1? It is basically tan theta 1 equals to root 3, which is your tan 60 degrees. So that gives us theta 1 equals to 60 degrees, right? Now in place of n, if we put 1, in place of n, if we put 1 in this relation, that is the derived relation, if I put, then we are going to get theta 2 as 45 degree plus theta 1 by 2, that gives us 75 degrees. Is it clear? Now if I put n equals to 2 in the given relation, I mean the derived relation, we are going to get theta 3 as 45 degree plus theta 2 by 2, that gives us 45 degree plus 75 degrees by 2. So that gives us plus 37.5, that gives you 82.5, right? 82.5 degrees. Now if you observe, you will find that theta 1 is 60 degree, theta 2 is 75 degree, theta 3 is 82.5 degrees, okay, and so on. So we can conclude a relationship that is theta n is basically 90 degree minus 30 degree divided by 2 to the power n minus 1. Just check it whether I am correct or not. In place of 1, in place of n, if we put 1, then theta 1 is coming to 90 minus theta by 1. So that gives you 60 degree, which is correct. In place of n, if I put 2, then we are going to get 90 degree minus 30 degree divided by 2, that is 15 degree. So 90 minus 15 degree is 75 degree. That is also correct, and so on. Okay. Therefore, we got that theta n is nothing but 90 degree minus 30 degree by 2 to the power n minus 1. Now, for our convenience, let us just write alpha equals to 30 degree by 2 to the power n minus 1. Therefore, your theta n is coming to 90 degree minus alpha. Is it clear? Now, observe carefully. We have xn equals to tan theta n, that is 90 degree minus alpha. So we are getting what? Xn is nothing but cot alpha. Is it clear to all of you? Absolutely. So we have derived two relations. I'm just writing it here. That theta n is, because the rest portion I will rub it, it's 90 degree minus 30 degree by 2 to the power n minus 1. This is the first relation that we got. And we got xn is nothing but cot alpha, right? Where alpha is 30 degrees by 2 to the power n minus 1. Is it clear? Now let me just rub the rest portion so that we can get space. Now let us see the second series which is given to us. Yn plus 1 is yn by 1 plus root over 1 plus yn square. Okay. Now let us take yn equals to, let us say, tan alpha n, where alpha n is in the first quadrant. Is it clear? Therefore, we are getting yn plus 1 as tan alpha n divided by 1 plus sec alpha n. So that gives us sin alpha n by cos alpha n plus 1, which gives you tan alpha n by 2. Have you understood this? Because sin alpha n can be written as 2 sin alpha n by 2 cos alpha n by 2, and 1 plus cos alpha n can be written as 2 cos square alpha n by 2. So we are getting tan alpha n by 2. Is it clear? So yn plus 1 is tan alpha n by 2. Now yn plus 1 can also be written as tan alpha n plus 1, which is equals to tan alpha n by 2, implies alpha n plus 1 is alpha n by 2. Is it clear? They have already said that y1 is nothing but root 3. Okay, so y1 means what? It is tan alpha 1. So that implies alpha 1 is 60 degrees, right? Now let me put n equals to 1 in this relation. So we are getting alpha 2 is nothing but alpha 1 by 2, which gives you 30 degrees, right? Now let me put n equals to, in this case, let us put n equals to 2. So we are getting alpha 3 as alpha 2 by 2, which gives you 15 degrees, and so on. Is it clear? So from here we can write that alpha n is basically equals to what you can write? Alpha 1 is 60, alpha 2 is 30. So we can write this thing as 60 degree divided by 2 to the power n minus 1. Tell me yes or no. Because if alpha is 1, we are when n is 1, we are getting alpha 1 as 60 degree. When n is 2, we are getting alpha 2 as 30 degree, and so on and so forth. So we got alpha n is nothing but 60 degrees divided by 2 to the power n minus 1. Again, we have alpha is 30 degree by 2 to the power n minus 1. So we can say that alpha n is basically what you can write? We can write this thing as 2 times alpha. Yes or no? We can write this thing as 2 times alpha. Yes or no? Have you understood this? So alpha n can be written as 2 alpha. Okay. Therefore, yn is basically tan alpha n, which implies yn is nothing but tan 2 alpha. Is it clear? Absolutely. Now, what is your, let me just rub this portion. So now we are getting xn into yn is basically cot alpha into tan 2 alpha. Is it clear? So writing the formula of tan 2 alpha, which is nothing but 2 tan alpha divided by 1 minus tan square alpha, right? So we are getting xn yn as 2 by 1 minus tan square alpha. Is this clear to everybody or not? Tell me first. Have you understood this? So xn yn is 2 by 1 minus tan square alpha. Now you see, your alpha is what? Your alpha is basically 30 degree divided by 2 to the power n minus 1, right? Now, if n is greater than 1, think about it. N is greater than 1. If n is greater than 1, if we say that n is tending towards infinity, if n is tending towards infinity, then your alpha is tending towards 0. Tell me yes or no. Yes? Okay. Then you see xn yn will become what? Xn yn will tend towards what? Tell me. If tan alpha, if alpha is tending towards 0, then definitely your tan square alpha is also tending towards 0. Therefore, xn yn is tending towards 2. Yes or no? Okay. Now, x is greater, n is greater than 1. Now, if n approaches to 1, n is greater than 1, nah? They have already said that n is greater than 1. Now, when n is approaching towards 1, then what happened for x and y? And tell me first. If n approaches towards 1, think about it, your alpha is tending towards what? It's tending towards 30 degree. Yes or no? Tell me fast. If n is tending towards 1, your alpha is tending towards 30 degree. If alpha is tending towards 30 degree, then your tan square alpha is tending towards 1/3. So your xn yn is tending towards what? 2 divided by 1 minus 1/3. That gives you 3. Yes or no? Hello? Yes or no? Okay. Therefore, xn yn is then tending towards 3. So what we can say? We can say that when n is greater than 1, your xn yn is greater than 2 and less than 3. Is it clear? Is it clear or not? So we have proved that when n is greater than 1, your xn yn is greater than 2, less than 3. Have you understood this problem? Please try this sum by your own. Otherwise, you will never be comfortable with this kind of problems. Okay?